Hello there, welcome to lesson number 9 in our series on using FluidDesigner for 3D printing to create ceramic and porcelain objects. Today we're going to show you how you can use a built-in mesh function called a Twisted Torus to create an open vase cover. So if you start off FluidDesigner, first thing you need to do is to go to Learning Projects and Learning Projects Ceramic and Porcelain Projects, and we're doing lesson number 9. So if you scroll down to 09, and you can drag and drop 09, the Twisted Torus open vase. So this is the object that we're going to create in today's lesson. As you can see, it's got a height of 200 millimeters, so that's the Z dimension, blue is the Z, and it's got X and Y values of 110 millimeters. And this is created using a mesh function. What I'm going to do first of all is switch on screencast keys, so any key presses I make should be displayed in the lower window here for you to see, and remind you that in the help window here you can follow all the instructions on how to create this object if you don't want to watch the video. So what we're going to do is we're going to add a mesh, a torus object and a twisted torus. So add mesh, torus objects and twisted torus. So we're adding a torus mesh, and this panel is important because these are where all the variables are that we're going to change to modify this existing object at the moment. If we just go to view and zoom to selected, you can see this is the basic twisted torus that's been created for you. It's got one twist in it at the moment, so it twists around on itself. At the moment it's really tiny, it's just 2.5 millimeters X and Y dimension and 0.5 in the Z, so it's quite a small object this at the moment. We obviously want to magnify it up. So the first thing we need to change is the major radius, and we want a value of 50. So I'm going to hold down the left mouse button and drag it, and as you can see what clearly happens is as we change the major radius, so if I change it up to 10 for example, you can see that the X and the Y dimensions, I'll just zoom out and reposition the object. Yeah, so when the major radius is 10, so 10, the X and the Y dimensions are 20. So these are basically the diameters of the object. We want it as 50, so we can just keep going. I'm just holding the left mouse button and dragging it. That will take me up to 50. If you want the exact value 50, just type it in. And as you can see, that's given us dimensions now of approximately 100 millimeters diameter, or 10 centimeters. So that's the major radius. Now if I just zoom in on this object, if I now change the minor radius to 5, and again I'll do it slowly first of all. You can see what's happening clearly. We're changing the actual thickness of the object itself as we change the minor radius, and if we take it up to a value of 5, just a little bit too much, well, I'll type it in exactly at 5, you'll see that a minor radius of 5 gives us a Z dimension, in other words a height of this object of 10 millimeters. Now there are other variables here that you can change, the twists for example, so the number of twists of the torus. We're going to leave it at 1 in this instance. You can change the major segments, so this is the number of segments for the main rings of the torus, or the minor segments, the number of segments for the minor rings. So if you change this, what you do is you change the surface of this and you improve the roundness of the object. So if we change this very high, yeah, around the object we've got more segments going around it. Let me take it right down to the bottom and you'll see what happens. Yeah, so major segments is the number of segments around the object. So if we've set it at 6, we've got 1 segment, 2, 3, 4, 5, 6. So the major segments are the segments going around the object. You can see it clearly when I reduce it really low. There are only 3 segments around. Okay, so that changes the shape of it, and the bigger this number, the more rounded this object will be when it's printed. It was at 40, we're going to leave it at that at the moment. Now the minor segments are the number of segments going around, so if we increase this, we smooth it off going around. So the minor segments are the segments here. There's 1, 2, 3, 4. We've got 43, 44 at the moment. Again, I'll reduce it right down and you can see more clearly what's happening. So if we've only got 4 segments, we've got 1, 2, and then 3 and 4 at the back. 3 segments, we get this triangular shape, cross-section shape of it. There are only 3 segments around the object now. 4, 5, 6, 7. So we're changing the number of segments around the object, and as we do that, as we increase this number, we round the object off. Okay, so that's what those do. We're not changing it in the instructions here, but that's the effect that they have. So those are the only changes that we want to make at the moment to this in this panel. So we can close this panel down now. But what we want to do is, now we've got the outer dimensions of this object like the one at the bottom, we want to change the Z dimension. We want to change this height up to 200 millimeters. So if I just change this manually here, sorry, not manually, if I just drag the mouse, you can see what's happening as I change this value. I want to change it to 200 millimeters, so if I just type it in, 200 mm for millimeters, that will give me my height. If I just type 200, yeah, you only get 0.2 millimeters, so you need to enter in the mm if you're going to type it in. So 200 millimeters, and that will give you the height of the object as shown. Now whenever you do this sort of thing, whenever you stretch objects like this, from the point of view of 3D printing, it's very important, if you're going to stretch an object or scale an object, that you always reset the scale. It's a peculiarity of FluidDesigner, it's a peculiarity of Blender, which is the software behind FluidDesigner, that you must reset the scale. So if you change these values here, always go to Control A and apply the scale. If you don't do that, you will have printing problems. So if we were to change this value here, make it higher again, if that's the height that you want, always do Control A and apply the scale. So change it back to 200 again. Whoops, I forgot to do the 200 millimeters. Do Control A and apply the scale. If you don't do that, you could end up with printing problems later on. So there's our finished object now, our Twisted Torus. What we need to do now is to delete the original one and save our Twisted Torus that we've created in today's lesson, and use Save As. We always recommend you use Save As in FluidDesigner, and if you just scroll up the menu system here and look for the folder My Projects, we're going to save lesson 09, the Twisted Torus Open Vase. We're going to save it as a Blender file into the My Documents folder, and we should always then export this as a wavefront object file or some other printable file format if you prefer. We use wavefront, so save it as a wavefront object file to the desktop and export that object file. You then should always go to Netfab Basic and go to Project and Open, and if I go to the desktop and open up 09, the Open Vase, Netfab will analyze the object that you've created, see if there are any errors with it, see if there are any corrections need to be made. So we need to go to Extras and run the repair part procedure in Netfab Basic. Netfab Basic will always do something. As you can see, it's triangulated the mesh here, and if I just move the window across, if I just click on Update, you'll see there are no border edge, no orientation, no hole problems, and there's just the one shell. But I would always recommend you run automatic repair and execute it. It'll triangulate it and save that change, and apply the repair and remove any old parts. So we've got no warning wedge triangles, we've got no border edge problems or orientation problems, so this now should be a printable file format. So you can now go to Part and export it as a wavefront object again, save it to the desktop, and the repaired file, that's the file that you should send to the printer if you wanted to print this object. Okay, so that's the end of this lesson. Thank you.